Why does Python code use len function instead of a length method? I know that Python has a len function that is used to determine the size of a string, but I was wondering why it's not a method of the string object.
Strings do have a length method, _len_. The protocol in Python is to implement this method on objects which have a length and use the built-in len function, which calls it for you, similar to the way you would implement _iter_, and use the built-in iter function, or have the method called behind the scenes for you on objects which are iterable. See emulating container types for more information. Here's a good read on the subject of protocols in Python and the principle of least astonishment.
Jim's answer to this question may help. I copy it here. Quoting Guido van Rossum. First of all, I chose len x over x.len for C reasons. Def_len_ came much later. There are two intertwined reasons actually, both are C. A. For some operations, prefix notation just reads better than postfix, prefix and infix. Operations have a long tradition in mathematics, which likes notations where the visuals help the mathematician thinking about a problem. Compare the ease with which we rewrite a formula like x, a plus b, into xa plus xb to the clumsiness of doing the same thing using a raw U notation. B. When I read code that says len x, I know that it is asking for the length of something. This tells me two things: the result is an integer, and the argument is some kind of container. To the contrary, when I read x.len, I have to already know that x is some kind of container implementing an interface, or inheriting from a class that has a standard len. Witness the confusion we occasionally have when a class that is not implementing a mapping has a get or keys method, or something that isn't a file has a write method. Saying the same thing in another way, I see len as a built-in operation. I'd hate to lose that. /./
Python is a pragmatic programming language, and the reasons for len being a function and not a method of str, list, dict etc. are pragmatic. The len built-in function deals directly with built-in types. The Python implementation of len actually returns the value of the ob_size field in the pivot C struct that represents any variable-sized built-in object in memory. This is much faster than calling a method. No attribute lookup needs to happen. Getting the number of items in a collection is a common operation and must work efficiently for such basic and diverse types as str, list, array, etc. However, to promote consistency, when applying len o to a user-defined type, Python calls o._len_ as a fallback. _len_, _abs_ and all the other special methods documented in the Python data model make it easy to create objects that behave like the built-ins, enabling the expressive and highly consistent APIS we call Pythonic. By implementing special methods, your objects can support iteration, overload infix operators, manage contexts, and with blocks etc. You can think of the data model as a way of using the Python language itself as a framework where the objects you create can be integrated seamlessly. A second reason, supported by quotes from Guido van Rossum like this one, is that it is easier to read and write lens than s.len. The notation lens is consistent with unary operators with prefix notation, like abs-in. Len is used way more often than abs, and it deserves to be as easy to write. There may also be a historical reason. In the ABC language which preceded Python, and was very influential in its design, there was a unary operator written as #s which meant lens.
There is a len method.
Please call